How much evidence does it take? Previously, I defined evidence as an event entangled by links of cause and effect with whatever you want to know about, and entangled as happening differently for different possible states of the target. So how much entanglement, how much rational evidence is required to support a belief? Let's start with a question simple enough to be mathematical. How hard would you have to entangle yourself with the lottery in order to win? Suppose there are 70 balls drawn without replacement and 6 numbers to match for the win. Then there are 131,115,985 possible winning combinations, hence a randomly selected ticket would have a 1 in 131,115,985 probability of winning, which is the same as 0.000007%. To win the lottery, you would need evidence selective enough to visibly favor one combination over the other 131,115,984 alternatives. Suppose there are some tests you can perform which discriminate probabilistically between winning and losing lottery numbers. For example, you can punch a combination into a little black box that always beeps if the combination is the winner and has only a 1 in 4, 25% chance of beeping if the combination is wrong. In Bayesian terms, we would say the likelihood ratio is 4 to 1. This means that the box is 4 times as likely to beep when we punch in a correct combination compared to how likely it is to beep for an incorrect combination. There are still a whole lot of possible combinations. If you punch in 20 correct combinations, the box will beep on 5 of them by sheer chance, on average. If you punch in all 131,115,985 possible combinations, then while the box is certain to beep for the one winning combination, it will also beep for 32,778,994 losing combinations on average. So this box doesn't let you win the lottery, but it's better than nothing. If you use the box, your odds of winning would go from 1 in 131 million something to 1 in 32 million something. You've made some progress toward finding your target, the truth, within the huge space of possibilities. Suppose you can use another black box to test combinations twice independently. Both boxes are certain to beep for the winning ticket, but the chance of a box beeping for a losing combination is 1 in 4 independently for each box. Hence, the chance of both boxes beeping for a losing combination is 1 in 16. We can say that the cumulative evidence of two independent tests has a likelihood ratio of 16 to 1. The number of losing lottery tickets that pass both tests will be on average 8 million something. Since there are 131 million something possible lottery tickets, you might guess that you need evidence whose strength is around 131 million something to 1, an event or series of events which is 131 million something times more likely to happen for a winning combination than a losing combination. Actually, this amount of evidence would only be enough to give you an even chance of winning the lottery. Why? Because if you apply a filter of that power to 131 million losing tickets, there will be on average one losing ticket that passes the filter. The winning ticket will also pass the filter, so you'll be left with 2 tickets that pass the filter, only one of them a winner. 50% odds of winning if you can only buy one ticket. A better way of viewing the problem. In the beginning, there is one winning ticket and 131 million something losing tickets, so your odds of winning are 1 to 131 million something. If you use a single box, the odds of it beeping are 1 for a winning ticket and a quarter for a losing ticket. So we multiply 1 to 131 million by 1 to a quarter and get 1 to about 32 million. Adding another box of evidence multiplies the odds by 1 to a quarter again, so now the odds are 1 winning ticket to 8 million something losing tickets. It's convenient to measure evidence in bits, not like bits on a hard drive, but mathematicians' bits, which are conceptually different. Mathematicians' bits are the logarithms based 1.5 1/2 of probabilities. For example, if there are 4 possible outcomes A, B, C, and D, whose probabilities are 50%, 25%, 12.5%, and 12.5%, and I tell you the outcome was D, then I've transmitted 3 bits of information to you because I informed you of an outcome whose probability was 1/8. It so happens that 131 million something is slightly less than 2 to the 27th power, so 14 boxes or 28 bits of evidence, an event 268 million something to 1 times more likely to happen if the ticket hypothesis then is true than if it is false, would shift the odds from 1 to 131 million to 268 million to 131 million something, which reduces to 2 to 1. Odds of 2 to 1 mean 2 chances to win for each chance to lose, so the probability of winning with 28 bits of evidence is 2/3. Adding another box, another 2 bits of evidence would take the odds to 8 to 1. Adding yet another 2 boxes would take the chance of winning to 128 to 1. So if you want to license a strong belief that you will win the lottery, arbitrarily defined as less than 1% probability of being wrong, 34 bits of evidence or the winning combination should do the trick. In general, the rules for weighing how much evidence it takes follow a similar pattern. The larger the space of possibilities in which the hypotheses lie, or the more unlikely the hypothesis seems a priori compared to its neighbors, or the more confident you wish to be, the more evidence you need. You cannot defy the rules. You cannot form an accurate beliefs based on inadequate evidence. Let's say you've got 10 boxes lined up in a row, and you start punching combinations into the boxes. You could stop on the first combination that gets beeps from all 10 boxes, saying, but the odds of that happening for a losing combination are 1,000,000 to 1. I'll just ignore those ivory tower Bayesian rules and stop here. On average, 131 losing tickets will pass such a test for every winner. Considering the space of possibilities and the prior improbability, you jump to a too strong conclusion based on insufficient evidence. That's not a pointless bureaucratic regulation, it's math. Of course you can still believe based on inadequate evidence, if that is your whim, but you will not be able to believe accurately. It's like trying to drive your car without any fuel, because you don't believe in the fuddy-duddy concept that it ought to take fuel to go places. Wouldn't it be so much more fun and so much less expensive if we just decided to repeal the law that cars need fuel? Well, you can try. You can even shut your eyes and pretend the car is moving, but really arriving at accurate beliefs requires evidence fuel, and the further you want to go, the more fuel you need.